Our next lesson in Chapter 1 is Lesson 1.4, and we're combining that with Lesson 1.5 so that we can talk about squares and cubes of a number. You have already worked with squares and cubes and building them in our previous video, and you've also had an opportunity to actually build with the manipulatives to kind of see how that works. Well, we're going to apply what we know to some order of operation problems. So if you look, you have this page on the back of your order of operations hint sheet, which looks something like this. Okay, it says 6th grade notes. You're supposed to save these. And it reminds you that we could use GEMDAS, or some people like to call these PEMDAS. So either way you learn this, we really want to remember that we're going to use parentheses, exponents. We're going to look for some multiplication and some division, but these are buddies and they go in order from left to right, and also addition and subtraction, but they're buddies again. So if that's all we have left, sometimes subtraction will come before addition. We just have to remember to go in order from left to right. And again, the difference here, P for parentheses, or if you move up to the top, it says G could be for grouping symbols. There are multiple ways that those could look. Let's go ahead and turn this over and look at our examples, just to get you started. So it says evaluate each expression. Ooh, this word evaluate, that's important. It really means I want to solve. I'm going to find an answer for each of these. We need to show each step in the order of operations. And I gave you a reminder, you're going to state what rule we're using. So if we look at this first problem, I wonder if I can zoom in for you a tiny bit so that we can focus on just this one. If you notice, it says we have 5 plus 5. This dot we've been using a lot means times. 3 minus 2 times 2 to the second power. Oh, there's that 2 squared that we need to talk about. Well, the first thing I would probably do is jot myself a reminder. PEMDAS. Well, multiplication and division are buddies. They'll go in order from left to right, as are addition and subtraction. So first thing I'm looking for are parentheses. Do we have any here? The answer is no. So next I look for exponents. Do we have any? The answer is yes, right here. So we have to remember what 2 to the second power means. So we're going to actually write this out in expanded form. We're going to write 5 plus 5 times 3 minus 2 times 2 times 2. And sometimes I actually put those in parentheses. I show you that I have to figure out what this power is worth right now, or what this exponent will get me. Well, the rule that we're really using is expanded form with exponents. So we could just write exponents here. We're going to continue with this idea of exponents because we want to find out what 2 to the second power really is equal to. So 2 times 2 is actually 4, and everything else in the problem stays the same. Well, what do we have next? No more exponents. Cross that off. Do we have multiplication or division? And if so, we have to work in order from left to right. Well, I see some multiplication happening right here, and I see another one happening right here in a minute. Let's see if we can figure these out. What is 5 times 3? 15 sounds good. What is 2 times 4? 8, of course. So I bring everything else down that I haven't used yet. There's this 5 out front, still there. Still an addition happening next. This 5 times 3 is now 15. But look at that subtraction. We haven't used this yet. And we already took care of 2 times 4. It looks like we're ready to go. What rule did I really just use here? Again, we were looking at exponents on that second line. I was simplifying exponents. That's where that 4 came from. And this next one, well, I just drew braces or brackets around the multiplication. So we multiplied. Well, next I have addition or subtraction, and remember these are buddies. They go in order from left to right. So addition comes first in this situation. I'll do the addition now. What's 5 plus 15? The answer is 20, and I take away 8. Well, the rule I just really used was addition. I simplified the addition from the previous line. The last thing I need to do is simplify the subtraction. So my additions are gone, subtraction is last. Let's see. 20 take away 8. Well, if it was 20 take away 10, I'd have 10. But I'm taking away 2 less than that, so I could add 2 back on. Looks like I'm going to get an answer of 12. You would record your answer, and I ask that you kind of highlight it or circle it so it stands out. Notice what we made here. oops, before we notice what we made here, let's go ahead and write down subtraction. We just handled the subtraction last. Do you also notice that if we do a good job of this, we just made something awesome? Sometimes I call it pizza. Some teachers and students like to call it a cone. It kind of looks like an inverted triangle, but I like to call it pizza. It looks like a slice of pizza happening here with pepperoni on top, of course. Okay, we're going to try another one together. So take a look at number 2. Well, are there any parentheses? As I jot down PEMDAS real quickly, some of you have probably remembered since the elementary school, please excuse my dear Aunt Sally. That's a great way to remember kind of the mnemonic device, how to stick this in your head. Well, do we have parentheses in this problem? The answer is no. Do we have exponents? The answer is yes. I see one at the back here. And remember what that means to the third power. It means I'm going to use the base, that giant 2, that base, I'm going to build it up. I'm going to use it 3 times. So let's go ahead and do a rewrite step. Everything else stays the same. But this 2 to the third power could really be written 2 times 2 times 2. Notice those all came from a power or an exponent, so I'm going to just put them in parentheses and say, hey, let's take care of this first. So exponents right here. I really want to do some simplifying. I want to figure out what 2 times 2 times 2 is. Most popular wrong answer, 6. But this is not 6. We can't count 2, 4, 6 unless we're doing repeated addition. This is multiplication. 2 times 2 is 4, times 2 again is 8. We get an 8 from these exponents, and again, we're simplifying our exponent. Everything else in the problem should stay the same, so you really need to bring everything else down. Looks like we've got it. Well, exponents are set. Is there any multiplication or division? The answer is yes, I see both. But remember, we have to go in order from left to right. So the first thing I see in the problem is this multiplication. Let's do that now. What is 4 times 7? Oh, 28 will work. And I bring everything else down. This is called line by line work, and it really helps your organization and make sure that you don't miss any steps. So what did we just simplify? Multiplication. Next, there's no more multiplication, but I do see a division, and it's right back here. 8 divided by 8. Well, anything divided by itself, I remember, gets me 1. And I still have this 28 out front, and don't forget that addition we haven't used yet. Division, we're set. So again, we just use this division rule. Let's write it down. What's the last step here? There is addition or subtraction, and I move in order from left to right. And in this case, really, we only have addition. So what's 28 plus 1? The answer is 29. I wish we had a little more room here. 29. Do you notice this beautiful line by line work? What did we just make? Pizza. You do not have to draw those lines. You don't have to show me your slice of pizza. Your work actually does that for you. Let's take a look at number 3. Oh, this one's great because I noticed something. And I'm going to change my rule here a little bit just to make us think that both are really the same. We really could use PEMDAS or GEMDAS. Remember, multiplication, division in order from left to right, and addition, subtraction too. Do we have any G, grouping symbols, or parentheses? And the answer is, yep, we do, right here. So the first thing I need to do is take care of the operation in the grouping symbols. What is 2 plus 4? Well, the answer is 6, and I know I write a little bit bigger than they do, so I'm going to move my 6 over here a little bit. Notice that everything else in the parentheses, in the expression, stays the same. So I'm going to write 5 squared, that's a division, divided by 5, times, not any more parentheses, just times 6. I simplified those parentheses, didn't I? So let's write down which rule we used. Well, I'm done with my grouping symbols. They seem to be gone. What about exponents? Oh, I do have exponents. They're sitting right here. 5 to the second power. That really means I need to use this base twice. 5 times 5. And sometimes I will put those in parentheses just to remind you I'm working on exponents for a minute. This is called expanded form, and I'm going to simplify that in just a moment. Everything else stays the same. And again, I'm working on my rule of exponents. Well, what is 5 times 5? The answer would be 25, and I bring everything else down just the way it is. And notice I draw these brackets every single time to kind of show you which operation I've taken care of. Well, this was still simplifying the exponent, wasn't it? Exponent's all set. Is there a multiplication or division? The answer is yes. And this is where, this is kind of exciting. If you notice, we have to go in order from left to right. This is a good challenging example for us. So the first operation we're given is division. So we'll do that first in order from left to right, just like we're reading. What is 25 divided by 5? 5 times 4 is 20. 5 times 5, that's it. 5 goes into 25 5 times. And we bring down everything we have not used yet. That multiplication symbol, still there. That 6, bring it down. Well, go back. What rule did we just simplify? Division. We're all done with division, but this is funny. We kind of skipped over something because, again, we go in order from left to right. So the last thing I need to do is multiply. This dot really means multiplication, and we've been practicing that a lot in class. What is 5 times 6? The answer is 30. We just used the rule of multiplication. I noticed earlier we forgot to use the rule of addition up here. Well, we used that rule, we just forgot to indicate what it was. Did we end up with some pizza? A little bit. Looks like someone took a bite out of the crust. This really happened. This first expression was a little bit shorter before we had to write expanded form. And that happened because we had to take that exponent and show what it meant. That meant 5 times 5. That happens a little bit sometimes. These next two could be a little bit tricky because the exponents have moved on us a little bit. So let's just go ahead and finish this up if we can. I'm going to call this GEMDAS again. It's really up to you what works best for you to remember. And are there any grouping symbols? The answer is yes. Right here, 12 take away 8. There are grouping symbols. So I would call these parentheses or grouping. And 12 take away 8 is 4. And notice there's this little exponent sitting back there. We haven't used that yet. We better bring it down. Take away 4 and add 21. Everything else stays the same. Grouping symbols, set. Exponents. Oh, we have some of those again. What does it mean to the second power? If you remember, that really means a base times a height, or the number times itself. Next, I need to show you everything else that stays the same. And what am I working on right now? Exponents. We're still working on these exponents. I want to figure out what this exponent is finally worth. Well, 4 times 4 is the same as 16, which we would call a perfect square, meaning I could make a square out of 6 perfectly square units if I wanted to. We'll bring everything else down. And a second line of exponents. This keeps happening every time I have exponents. We have 2 lines of work. One where we expand them, one where we simplify. Here we expanded, and here we simplified. Exponents, check. How about multiplication or division? Not in this problem. Check, check. Addition, subtraction. Oh, this is where they get challenging, right? This is where they try to switch the order on you, and they try to see if you know which is right. Well, in order from left to right, meaning sometimes subtraction beats addition. Sometimes addition goes first and beats subtraction. Well, who comes first in this situation? Subtraction. What does 16 take away 4? The answer is 12. And 12 plus 21 because we bring everything else down. We just did subtraction. But there's one more step to go. What is 12 plus 21? The answer here is 33. Again, I wish I had a little more room here. It looks like the last thing we used was addition. Notice our pizza? It looks pretty good, although there's a little bit of the crust missing, right? A little bit of this cone was collapsed on the top. Why did that happen? Because of these exponents. When I have an exponent, I have to expand my pizza a little bit. I have to expand the slice, or maybe stretch the dough, if you will. Okay, that happens when we use expanded form. I'm going to keep going. Again, I'm not sure that you need all the directions one-on-one with this, but we'll just take a look at these last few in case you're feeling a little bit stuck, or if my guest teacher shows this to you and really wants to walk you through each step with me. So let's see what we have here. I'm going to go back to PEMDAS, and I'm even going to write it a little bit differently because sometimes I think of PEMDAS in a different way. Sometimes I write it in more of a vertical format. This way I can remind myself multiplication and division in order from left to right, and addition and subtraction in order from left to right. And if you notice, they're all on a different level, meaning these are the levels of importance. Well, are there parentheses? Sure are, but there are a couple things to do in these parentheses. So if there's multiple operations, here I have an exponent and division, who comes first inside? Well, you look through your list, and inside, exponents would come before division. So let's look at this exponent inside the parenthesis first. Everything else is going to stay the same. But what about this 2 to the 4th? How would I stretch out that dou or expand this expression? That exponent would look like 2 times 2 times 2 times 2 in expanded form. And at the back, I'd have to divide by 8. Notice I still had some parentheses around here, so parentheses or brackets or braces, somehow you have to show me that that's still a group. That's still happening together. Well, here I'm using exponents. We're going to shortcut it because I'm kind of out of space. And we're going to see if we can simplify this exponent one more time. So 2 times 2 is 4. 2 times 2 over here is 4. 4 times 4 is 16. We're going to get 16 from that exponent, and we're going to write 16 divided by 8. That's really what's happening in parentheses there. I just had to simplify the exponent first. So still looking at exponents. And in front, we haven't done anything with 7, take away 1, or times 2. All right, looks like I've got it. Well, what comes next? There's still more parentheses, and what's inside now? Well, we're left with division, so let's go ahead and look at that next. What is 16 divided by 8? The answer is 2, because I know 2 times 8 is 16. Let's bring everything else down the way it is. Notice this could be really dangerous. I have a 2 sitting here, and right after it is a parenthesis. We've talked about this in class a little bit, but maybe you don't remember. Either I need to show parentheses here, so that I show that this 2 is kind of special and separated from this 2. This isn't 22. This is something else happening here. Or some students would say, that's multiplication, and they'd actually show that symbol instead. Well, let's see. Parentheses, check. Exponents in the parentheses, took care of those. Is there any multiplication or division outside of the parentheses now? The answer is yes. I see a couple of multiplications, and the first one I see is sitting right here. So first I would write 7 take away, what was 1 times 2? 2. And we would write times 2 at the back. That 2 can come out of parentheses as long as you remember to show a multiplication symbol of some sort. Preferably not the evil X, that we'll save for algebra. I see that I forgot my rule. Go back a step, and if you did a good job, you'll be able to tell what was the last thing we figured. We worked on a division. So division. What did we just do here? If you look back at your brace or your bracket, you could say multiplication. And next up, there's still more multiplication to go. So the next multiplication is sitting right here. What is 2 times 2? The answer is 4. And what's still left out front? Notice the order has to stay the same. 7 take away 4. Notice where we drew our brace or our bracket. Looks like we just used another rule of multiplication. And last but not least, what's 7 take away 4? Well, if you do the subtraction, you'll get 3. This seems to be my final answer, and if you look, our pizza looks a little bit better this time. Probably because the very first thing we did was expand that exponential form. So if you notice, the longest line of our work is really the first line this time. Oftentimes that will be the case. You don't have to draw these lines again, but I want you to notice that if you're doing your work well in a line-by-line format, that will continue to happen. There are a couple more over here for you to try, A, B, and C, so I'm going to give you a minute to kind of work on those. Why don't you go ahead and talk with your table partner, see what you can come up with, and make sure you're using that line-by-line work. So hopefully you've had a little bit of time to work these out. Maybe we even put this on pause so that you could test yourselves and see how well it was going. If you look at example A, you'll get a good answer of 33. And again, you really should be showing this line by line work. I showed you the rules of exponents when I used expanded form, exponents again when I simplified what those looked like, and then we had to talk about parentheses next, or maybe grouping symbols. Multiplication, that's 6 times 4, and last addition got me an answer of 33. Part B. it looks like the first thing I had to deal with were exponents. There were no grouping symbols. So with exponents, I did expanded form. I showed you 3 times 3 times 3. Lots of us probably have a wrong answer sitting here. But if you deal with that exponent, 3 times 3 is 9, times 3 again is 27. And we bring everything else down. Well, next my choices were subtraction or addition, and you have to remember that subtraction always precedes addition if it goes in left to right order. So, subtraction first it is. That will get me 7 plus 27, and when you are done, you'll have to add up to get a total of 34. Last, part C. Looks like we have 4 cubed divided by 2 minus the quantity of 6 plus 5. So just giving you an opportunity to see how to read this. First thing I had to do, expand my exponents. Actually, I didn't have to do that first, and I did. I forgot to use grouping symbols first. Good thing it didn't go wrong. So maybe you decided to use parentheses first. I think after you get more experience, you'll start to notice that sometimes we can swap out the steps as long as you realize it doesn't affect other pieces. I probably should have done the 6 plus 5 and gotten an 11 way up here a long time ago. Next up, exponents. We probably should write out expanded form. 4 times 4 times 4. Well, that will actually get you not 12, 64. Everything else should stay the same along the way, unless of course you were smarter than I was and you decided to put an 11 here instead of keeping those parentheses for a while. Next, when I can choose between division or subtraction, I have to choose division. It happens first in PEMDAS or even in GEMDAS. Well, 64 divided by 2 gets me 32, and I brought down that subtraction, minus 11. And 6th grader's favorite number, 21. If you stuck with me this long, it's probably time for a joke. Knock, knock. It's a waffle. It's a waffle sight to see a monster standing on your porch. How about this one? Knock, knock. Donut. Don't let werewolves into your house. Some good festive jokes for you, for those of you who said that my videos are getting kind of boring. With that, order of operations examples are here for you to use. You're actually going to have an opportunity to work on some task cards that are kind of like this. You really want to remember the steps of either PEMDAS or GEMDAS. And as you work, you'll want to think about stating the rule so that you have proof about what steps you took. And try to make me some delicious looking pizza. Those pizza slices or cones or inverted triangles show that you're being successful with line by line work.